Now we're going to do section 3.3, which is truth tables for conditional and biconditional statements. We did on Monday the truth tables for the conjunction and disjunction. Conjunction, if you remember, that's the and statement, which has this symbol. So the way this works, it is very nice to remember each one because then it's easier to work through them. You have true, true, false, false. You always start the same way. True, false, true, false. So when you have a conjunction, which is an and statement, the statement is only true when they are both true. So it is true only when they're both true. So it is true here and all the other ones are false. Okay? We also talked about the disjunction. Disjunction is the or. It's the or statement, which is same thing. You start with your P, Q, and then P or Q. And the way the truth table works is that the or statement, at least one of them has to be true for it to be true. So they both have to be false for it to be false. So in this case, this one is false, but all the other ones are true. So at least one to be true, one has to be true for it to be true. So these are the ones that we learned on Monday. Now we're going to talk about the conditional and the biconditional statement. I'm going to start with the conditional, which is the if-then. The if-then statement. So we have the P and the Q. So we have if P, then Q. So we are going to do the truth tables. The interesting part here is for the if-then statement is when is it true and when is it false. So what I call the conditional statement to remember when it is false, I call it the broken promise. So the broken promise is when, for example, I tell you, one of my students, I say, if you get an A, I will give you $100. I will give you $100. So say that you get an A and then I don't give you the $100. Then that is a broken promise. That's the only one. So you got your A and I did not fulfill my promise. That is the broken promise. That is false. That is when it is false. So this is the only place where the conditional statement is false. So otherwise it's going to be true. And this is what you have to remember, that it is false when you have a broken promise. So that is the conditional statement, which is if-then. Then the biconditional statement is when you have if and only if, and that is your double arrow. You have your P, your Q, and then P if and only if Q. So we have true, true, false, false, true, false, true, false. So the biconditional statement is true if they're both the same. So if they're both true, it's true. If they're both false, it's true. Otherwise, it's going to be false, okay? It is true if they're both the same. It is true when they're both the same. So this is what you must remember. We're going to do a couple of examples so you understand how to do the biconditional and the conditional statement on the truth tables. So we have P, Q, say, we're gonna do the statement if not P, then not Q. If not P, then not Q. So we're gonna start out with the same way as we always do. And then we're going to do the conditional statement, if not P, then not Q. So not P is the negation of P. So I'm gonna put it in small here so you don't make the mistake of looking at the wrong values. And the not Q is the negation of the Q statement. So we're going to put these values here. And this way we have all the opposite values because it's not P and then it is not Q. So we're going to apply the conditional statement for this one. Remember, it says if the broken promise, when you have the broken promise, that's the only place where it is going to be false. Where do we have the broken promise? Here we don't have the broken promise because they're both false, so this is true. Here we don't have the broken promise because we have false and then true, so this is true. Here we have true then false. This is the broken promise. When you have true first and then false, that is the broken promise, so that is false. And last of the truth tables for this particular statement, if true then true, it is true. So this is your final column. That means that is the solution to these truth tables. Okay, so now let's do another example. If P then Q, P and Q, so for P always true, true, false, false, and then for Q true, false, true, false. Let's do a statement with a biconditional statement. Let's say not Q if and only if P. Not Q if and only if P. So I'm gonna again write it in small here so I know what I am applying the biconditional statement to what truth values. So the not Q is the negation of the Q. So we have false, true, false, true, and the P would be true, true, false, false. Now, the biconditional says it is true when they are both the same. So this one is false because they're both different. This one is true because they're both true. This one is true because they're both the same, they're both false. And this one is false because they're not the same. So this is the biconditional statement, and that is your final answer for that. Then we can determine the truth values for a compound statement. So here you don't need to do a truth table, you just need to find out the truth value. If 5 is a prime number, then Santa Fe College is in Orlando. If 5 is a prime number, well, that is true. Then Santa Fe College is in Orlando. Well, we know that's not true. So we have T, if T then F, that is the broken promise because it is in that order, TF. So we know that this is a false statement. So the truth value for this compound statement is false. Then MGF 1106 is a math class if and only if we're going on a field trip to the zoo. Well, MGF is a math class, so that is true. If and only if we're going on a field trip to the zoo. Well, that would be nice to go on a field trip to the zoo, but we're too far away from the zoo. We are in Keystone Heights. And at nighttime, I don't want to go to the zoo. I wouldn't want to go at night. So that would be a false statement. So we have T, if and only if F. And remember, for the biconditional to be true, they both have to be the same. So this is false. Okay, now we're going to continue to work one more example of these truth tables with 3 different statements, as we did on Monday with conjunctions and disjunctions. When we have 3 different statements, we're going to get 8 rows on the truth tables. So we're going to start out with 4 true and 4 false for the P. Always start the same way. For the Q, 2 trues, 2 false, 2 true, 2 false. And for the R, true, false, true, false, true, false, true, false. The statement that we're going to do is going to be, if not P, then Q, if and only if not R. So I have a combination of things in here so we can practice all of what we have learned. First, we're going to do the parentheses because in mathematics, we always do the parentheses first. That is the order of operations. So we're going to do what's in the parentheses, and then we will go outside the parentheses to do the final column. So the not P is a negation of the P statement. We're going to write it in small here so we don't forget to use the right values. And we have Q here, which it's Q, it's not a negation, so we are going to write Q as is. So now we're going to do the if-then statement with this. Remember, it is only false with a broken promise. So the broken promise is when it starts with true and ends with false. So this one is true, 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 this one is true. Now this one is false and this one is false because they're both broken promise. So false and false. So I'm going to scratch this out because I don't want to get confused when I go to do my final column. So this is going to be not R. Well, I need to do the negation of R, so that would be false, true, false, true, false, true, false, true. I am going to do the biconditional statement because this is what I have here, if and only if. And remember, again, we have to remember this every time we're doing truth tables. The biconditional is true only when they're both the same. These are both different, so it is false. These are both true, both the same, so it is true. These are 2 different, so it is false. These are the same, so it is true. These are different, so it is false. These are the same, so it is true. These are the same again, so it is true. And these are different, so it is false. So this is the final column for this very large truth table. But if you do it in order, you will get to the final answer with no problem. There are 3 more definitions that I would like to discuss with you. Self-contradiction. Self-contradiction is a compound statement that is always false. A compound statement that is always false. This is one of the definitions that might show up on your test in the definition portion of your test. Then a tautology is a compound statement that is always true. And the last one is implication. An implication is a conditional statement that is a tautology. A conditional statement, so it is an if-then statement. That is a tautology. So what we're gonna do now, well, this means that it's always true, but it is a conditional statement. So this is the difference between implication and tautology. Tautology is for an and statement, an or statement. It can be any kind of statement, but in implication, it is specifically a conditional statement. Now we're going to do an example. Is the following statement a tautology, a self-contradiction, or neither? So we have a statement here. If not Q, then P, or not Q. So in order to figure out if this is a contradiction or a tautology, we have to do the truth tables for the statement. So we need the 4 lines because we only have P and Q, so that makes it a little bit simpler. Also, we're going to do the parentheses first. Like I told you before, in math, usually we want to follow the order of operations. And in this case, that means doing the parentheses first. So we're going to do the not Q. So that would be the negation of the Q statement. So that would be F, T, F, T. Notice that I write it in tiny, because I don't want to get confused later when I continue to do my table. And for the P, you have T, T, F, F. We're inside of the parentheses. This is a conditional, if not Q, then P. So we're looking for the broken promise, which is where the statement will be false. So this right here is true. Right here, true, true is true. False, false is true. True, false is false, because again, that is the conditional statement. So that is the broken promise. I'm going to scratch those out because I don't want to get confused. And then I'm going to do an or statement with not Q. Well, not Q is the negation of the Q statement, so that would be false, true, false, true. So with the or statement, this is going to be true, because with or, remember, at least one has to be true for it to be true. So that's true also. So that's true also. And that's true also. So what did we end up with? The whole final column is true. So this is a compound statement that no matter what, it is always true. So what is this? This is a tautology.